All right, let's begin. Hello, everyone. Thank you so much for joining us. My name is Lillian Podlog, and I'm a software developer here at Fluree. In this webinar, I'm going to talk about SmartFunctions, a little bit about how they work, but the majority of the time is going to be spent walking through a demo that is using SmartFunctions in quite a sophisticated way. But before we dive into that, just a few notes of housekeeping. So one, this whole webinar is going to be recorded. So if you need to leave or you want to revisit this material later on for any reason, that's going to be available online for free for now until the end of time. In addition, there are some prerequisites for this webinar. So as I mentioned before, I'm going to be showing you a demo that is using SmartFunctions in kind of a sophisticated manner. So it is really helpful if you have some background experience in FlureeDB and if you are a developer. That being said, I'm not going to walk through this demo line by line, and I am going to talk about some higher level concepts in terms of SmartFunctions. So if you don't have the background knowledge that might be necessary, you still will hopefully glean a lot of information from this webinar. And on that note, if you have any questions or any feedback as we're going through it, there's a little Q&A button at the bottom of your screen. And all of the questions that you send, I'll be able to see them. And I'll either address those questions as we make our way through the presentation or at the end if I haven't addressed them, already. All right, so with those notes of housekeeping taken care of, I just want to wish everyone, again, a warm welcome. Thanks so much for joining us, and I'm really happy to be able to show this material to you. So FlureeDB, which is one of the key products that I'm going to be showing you, is a database that focuses on data collaboration and data integrity. So that means that multiple parties can participate in the same database. They can query it, they can update and delete data, they can do things of that nature. But what's really, really key is that no single party has control of that database. Rather, every single member that is participating in that network has to abide by a set of common rules that are agreed upon by the network. And it's also key to note that those rules are not a layer that we built on top of FlureeDB. That the very rules that govern the database are encoded into the database itself. And so they are first-class citizens alongside every other piece of data that you have. And so that means that if someone goes back 10, 20 years down the line, they will always be able to deterministically figure out whether a transaction is valid or not. There's not, kind of a firewall that is built around Fluree or anything like that. Those rules are key to the very data itself. And so either a transaction is valid or invalid. It depends not only on the features of the transaction, but also the rules that we have in place. And this feature that I'm talking about, we refer to it as in Fluree as data protecting itself. And so the main way in which data protects itself is through SmartFunctions. And so SmartFunctions are just functions that exist in a collection in our database. So a collection in FlureeDB is like a table. So there's a table of functions that exists encoded as data in the database in FlureeDB. And they can be as simple as, does 1 equal 1, which is going to return true every single time. Or they could be more complicated, like a function that's asking, can you please query all of the usernames in our database? And if there are more than 5 users whose usernames rhyme with Pat, then return true. I don't think our query is going to say please, but you get the idea. So those functions, you can add functions to the function collection as you go on. You don't have to declare them at the beginning or anything like that. But they just live there in a specific collection in our database. But then how and when do they actually get called? So until we call those functions, until they're triggered by something, they're just sitting there and they're not doing anything. But we can attach SmartFunctions to particular features in our transaction. So just to talk about the the when that it happens. I'll talk a little bit more about the how in a bit. So we have a database. This is our original database. And this database has, let's say, people, and has people's names, emails, handles, information of that sort. And someone tries to issue a transaction. So Fluree takes that transaction and turns that transaction into what we call flakes, or basically facts. And those facts, those new facts, plus our old database is a candidate database. And at the point that we have a candidate database, no smart functions have run. So we've only done like some schema checking and things like that. But once we have a candidate database, then any sort of smart functions that might have been triggered by that transaction, they will be run. And if every single one of those smart functions returns true, then our transaction is valid. And then our candidate database becomes our next valid database. If even a single one of those smart functions fails, then the transaction fails, and our current database is our original database. So this red database over here. And that's really important to note because our transactions are atomic. So there's, state 1, which is our original state, and state 2, which is our candidate state. And either we take the entire transaction or we take none of it. And so smart functions can be attached both to the what in a transaction and to the who in a transaction. So we might have some smart functions that are attached to a specific collection in our transaction or a specific predicate. Or they could be, it doesn't matter what the contents of those transactions are, we just have smart functions that run based on who is issuing that transaction. So for example, a smart function attached to the person collection can say that a person must have a handle. So anytime we issue a transaction that in any way touches this person collection, whether we're adding a person, updating a person, deleting a person, whatever, the smart function will check whether a person has a handle. So in the case of the transaction that we have on the left, I'm creating a new person, and that person has the handle Annie. And in that case, this transaction will be valid because the person, this new person I'm creating, is named Annie. In the case of the transaction on the right, I'm creating a new person, but that person won't have a handle, so that transaction will fail. Another type of scenario that we can use to trigger our smart functions is by attaching them to particular predicates. So we can have a smart function that is attached to the person handle predicate. So again, anytime we touch that person handle predicate in any way, whether it's adding, updating, or deleting that handle, this smart function will run. And it says that a handle must be 4 characters long. And so in the case of the transaction on the left, we're creating a new person, and that person has a handle Annie. And Annie is more than 4 characters, or it is at least 4 characters long, so that transaction is valid. In the case of the transaction on the right, we are not touching the handle predicate in any way. So this smart function that we have listed on top never ever runs. And remember that graphic that I showed you with this original database and then candidate database? So I haven't shown you this transaction, but let's say you have a transaction that's deleting someone's handle. So now instead of a handle, you have a null handle. You don't have any handle. So in this case, that transaction would still be valid because in your candidate database, you don't have a single handle that is less than 4 characters long. So we don't even think about any sort of intermediate phase in our database. Whatever happens between original and candidate database has absolutely no bearing on whether the smart functions are valid or not. The order in which those transactions are listed, anything like that. And that's really helpful to think about when we're writing smart functions and when we're thinking about how they work. And that's an area of confusion sometimes I've noticed when people are writing them. So that's just important to clear up. Okay, and then finally, smart functions can be attached to a person. So we can have a smart function connected to John, and it says John can't add a new person. So this transaction, the one, we have a transaction on the left adding a new person, Annie, and we have a transaction on the right adding a new person, Annabelle Strout. And those transactions may or may not be valid, but if John submits them, they're never going to be valid. If Lainey submits those transactions, then those transactions are valid. If there are no other smart functions no other smart functions that are happening there. And so in this, so that's kind of a little overview on smart functions. And I want to make a little pit stop talking about flakes. And then we're going to go into our demonstration. So every single piece of information in Fluree DB, and this is something I referenced before, is stored in the form of a flake. And a flake is just an assertion of a fact at a given point in time. And the first three items in a flake are a subject, a predicate, and an object. And you can represent any piece of information as a subject, predicate, and object. So for example, we have a subject with the entity ID 122. The predicate, which is the feature of that subject, is person handle, and the object is Lillian. And you could have, 122 person hair color brown, a 122 person language English. You can represent, and you can have, so you can have flakes that represent any piece of information. And so, that's just kind of a little pit stop on the way there. So in this demo, we're going to build a voting application. And this voting application will allow users to submit purchase orders, but those purchase orders won't be valid until a certain number of people in our network vote for them to be valid. And this is going to be the interesting and complicated part of this. We will be able to vote not only on the purchase orders themselves, but also the voting thresholds. So in this application, you'll see that we're going to start by requiring that in order for a purchase order to be valid, there needs to be at least 2 votes, and there needs to be at least a majority of yes votes for that purchase order to be valid. And so when we submit purchase orders, until we change that particular smart function, that's going to be the requirement. But you'll also see that we are going to be able to vote and change that actual threshold to whatever we want. So maybe at least 10 votes, or at least a 75% majority, or something like that. So in order to build this up, we'll need to create 3 collections. And like I mentioned before, collections are analogous to relational database tables. So we're going to create a purchase order collection. And that purchase order collection will have several different predicates, or several different features. Among those are a name, an ID, a description, and a status. And when you create a purchase order, you'll be able to, any person in the network will be able to create a purchase order with a name and an ID and a description, but they won't be able to set the status to approved until we have the requisite number of votes. And that's really where the magic is going to happen. Then we're also going to create a change collection and a vote collection. So a change collection is going to be a proposed change to any entity in our database. So the change collection, among other items, will have a subject that it's referencing, a predicate, an object, and a reference to a vote. And then the vote that it's going to be referencing will have yes votes and no votes. So to make this a little bit more concrete, let's say that I want to change, for purchase order number 125, I want to change that purchase order's status to approved. In order for that to happen, there needs to be there will need to be a change subject that is referencing that purchase order, that subject ID and that predicate and that object. And there's also going to be in reference to a vote that meets the threshold that we have described. And so this is where we want to get to a place where you can't submit a purchase order without having a vote and an ability later on to change the vote requirements for that. Right. And so now we're going to dive into the application itself. So in this demo, I'm using version 0.11.0, which is not yet released. So this webinar in some ways is a little teaser for that release. which should be out in the next few weeks. But I mean, if you're following along, this is adaptable to 0.10.0. There's just one smart function, I think just one, that won't be valid in 0.10.0, but I'll point that out to you when we get there. So the first thing that I'm going to do is I'm going to start up my database. And I'm just going to do a Fluree start and have that loaded up. And I also have a little logback file, so if we have a chance, we'll look at some of the logging. So I have some custom rules in there for what sort of logging I want to be returned to me. And I'm going to create a new database called voting demo. And so right now I'm using the user interface for FlureeDB, which is running on localhost 8080. So again, if you're following along, there's a default port that's being used, and it's 8080 for most of the versions that we've released. And so you're going to find this user interface at that port. So I'm going to create this database. And this database just has a standard default information in there. We haven't added any information. But I'm going to go over to Visual Studio Code, and all of this material will be released to you all. You'll be able to see it later on. And I'm going to actually use our very newly released Visual Studio Code extension to issue transactions and queries to our database, which is super exciting. So rather than having to go to our user interface, we're going to use our extension. And so you can access our extension if you're using Visual Studio Code by going to the Extensions tab. Your version might look different than mine does, but if you type in Fluree Beta, that's the extension that we're using. And I already have it installed here, so I'm not going to uninstall or anything like that. And so this extension that we have allows you to connect to a single database that's running. And the first thing that you'll have to do is you'll have to set the configuration. And one of the ways of doing that is by having a Fluree config file in the top level of your directory. So I have this Fluree config.json file, and it references, let me zoom in a little bit. It references the IP address where I can access my database, the network that it's running in, and the DB. And so the DB that I created is called voting demo. So you can see this here. So whatever you call your DB, that's the config that you have to set. And then if I do Command-Shift-P, at least on Mac, I can call the Fluree setConfig command. And now my Visual Studio Code is connected to my Fluree database, and I can issue queries and transactions to it. So for example, if I want to just see all of the collections that I have in my database, I can write a query anywhere in my project and select that query and run Fluree query. And the results of any query or transaction that you issue is going to pop up in this file that we create, flureeresponse.txt. And just to note, we have it documented as well, but that file gets overridden every time you issue a query or transaction. So if you select star from predicate and issue that query, the contents of this file get overridden. But sometimes the responses can be quite long, so it's helpful to have it in a file rather than in a text box or something like that. All right. But anyways, for those that later on that are going to be following along using our little zip file with all of this information, if you go into the data folder, there are all of the transactions that we're going to be issuing. So the very first thing that we need to do is we will need to create a purchase order collection. So I kind of hinted, or I told you that this is what we would be doing. So we are going to create a purchase order collection, and that purchase order will have an ID, which is an integer. It will have a name. And it will have a description, and those are both strings, and it'll also have a status, which is also a string. And so I'm just going to select this and use my little extension to issue Fluree transact. And you can see the response here. So we're at block 2. So we are block 1, and now we're at block 2, and we can see the hash. We can see all the response data here if we'd like to look into that. The next thing that I'm going to need to do is I'm going to need to create a change collection. And that change collection, if you remember from the presentation, will hold a reference to the change that I want to make. So the particular subject, predicate, and object that I want to change. So the change will also have a name for convenience and a doc, but it'll have a subject, which is a reference. It'll have a predicate, which is also a reference. So we're referencing the actual subject and referencing the actual predicate in our database. And then we're going to have two items. We're going to have a change object and a change object ref. And this is just for convenience sake. So if you can imagine when I showed you the flakes, so subject, predicate, object, an object can be any number of types. This will have a bearing in the smart functions that we write. Just for convenience, anytime we have a type that's a reference to another object, we're going to put it in object ref. And anytime we have an object that is of type string, we're going to put in change/object. So you can imagine, like, if let's say your subject is Lillian, or Lillian, and then your predicate is hair color, your object is going to be a string brown. But if your subject is Lillian, your predicate is friends, then your object will be a ref. And there actually could be multiple flakes with that same pattern. So Lillian, friend, and then a reference to one friend, Lillian, friend, a reference to another friend. So anyways, that's just for convenience sake that we have those two different predicates here. And then we have a reference to a vote. So this is a collection we haven't created yet. And then we have two more predicates that we're going to create just for convenience. One is an authority descriptive ID. And then we have a built-in collection called users. So we're going to add user positions and user levels. So we're not actually going to really be using these predicates. But for anyone that's following along at the end, if you are interested in tinkering around and creating your own smart functions, then you can potentially create smart functions that use these particular predicates. So now I'm going to issue this transaction. And I can see, the status is 200, so I'm good to go. Keep going on. And let me open this over here. And now the final part of the schema that I need to create is creating votes. And so we need to create a new collection, which is a vote. I'm going to add a vote name, again, for convenience. And then vote no votes and vote yes votes, which are predicates that are multi, which means that there can be more than one object. And they're going to be of type ref. And the particular collection that they're going to reference is the auth collection. And so I haven't talked about this a lot up until this point, but the auth collection is probably the most important collection in our database for identity management. So if you're using private keys to sign your transactions, which we will be doing in this demonstration, the ID of your auth collection needs to be cryptographically linked to your private key. So if you ever need to keep track of particular identities, then the auth collection would be oftentimes the most logical one to use. So when we collect the names of the people that voted no and the names of the people that voted yes, what we're actually doing is we're collecting references to those auth records. So now I'm going to issue this transaction. And you can see here, again, our responses, but we've created one collection and 3 predicates. All right, so now our schema has been, we've finished creating our schema. And I'm going to go ahead and I'm going to add some sample data in here. So I'm going to add 5 different users, and those users are each going to have a reference to an auth record. And they'll also have that other information that I mentioned before, a level and a position. So I'm going to create a user with the username Anna with an auth record, this is a temporary ID referencing an auth record I'm going to create later on in this collection, a level 5, and a position department head. And I'm not going to go through all of these, but you can see we have Brad, Candace, Donna, and Edgar. So these are all the 5 users we are going to be creating. And these are the auth records. that we're making. So remember I said the auth records, the ID of that auth record, if you want to use that auth record to sign a transaction, then that ID has to be cryptographically linked to a private key. And so this auth ID that you see here, in our documentation we explain how you can derive it, or you can derive it in a number of ways using the downloaded version of Fluree. But that's analogous to a Bitcoin account ID. So this is a, when we have a signature, we can prove that that signature is signed by the auth record that holds the private key that is linked to this auth ID. So all of our auth records are connected to users. So there is, for now, a one-to-one relationship. The way that we built this demo, every single user has their own auth record, and every single auth record that we see here is specific to a private key. And so now I'm going to issue this transaction, and now we have our users created and our auth IDs. And this is obviously not the way that you would want to store your private keys. You know, every person that has a private key should store it themselves. If there's an ability, as a side note, there's an ability in Fluree for someone to interact with the database but not maintain a private key, and that's using the concept of authority, and so they can, you know, authenticate themselves in other ways, but that's less secure. But anyways, for convenience, for the sake of this demo, in our auth details file here in our data folder, I just have the list of all the users and their private keys and their public keys and their account IDs. So again, I wouldn't model my application on this, but just so you know, for convenience sake for this demo, all of our private keys and account IDs are there. Right. And now for each of those users, we've created our users, but there's no rules or roles attached to those users. And so this is the very first smart functions that we're going to be creating. So remember I said at the very beginning that smart functions can be attached to what? The contents of our transactions, or they can be attached to who is issuing those transactions. So the first thing that we're going to do is we're going to create smart functions that are attached to who. So we're going to create a role, which is a role of voter, and every single user in our database, we're going to give that user the role of voter, and that voter role will have certain rules. And so here are all the rules that we want to give to our voters. We want voters to be able to edit votes. So a voter will be able to edit any votes in the database. We're going to restrict these rules as we go on. But basically, by default, if you have an auth ID, if it doesn't have any rules, it can't access anything. So we're going to first give these users permission to edit and to view things, and then we're going to restrict that permission per collection that we're talking about. So first we have this edit votes rule, which we can just look at this rule in more detail here. So this is a reference to the rule that I'm about to create, and this is the rule itself. And I'm just going to change this order. So this rule has an ID or a name called edit votes, and we want it to be triggered every single time that, well, first of all, that an auth record connected to this rule issues a transaction, but only when that transaction includes an item in the vote collection. And we want this to be triggered anytime any transaction connected to this rule is issued in the vote collection, so that we select collection default to true. And the operations that we want this to apply to are to both transact and to query. So we can, if you look in our documentation, you'll see that you can actually, have different rules that apply to queries, to transactions, or to logs, things like that. But in here, it's just going to be to transact and to query. And then we're going to have a reference to the smart function that we want attached to this situation. And that smart function is one of our two built-in smart functions. We have two very simple built-in smart functions, one that's named true and the other that's named false. And I think our room of very intelligent people can figure out that the true smart function just returns true and the false smart function just returns false. So basically, this rule is saying that anytime we encounter a scenario where one, this particular auth record is issuing a transaction, and two, this transaction has the features of referencing the vote collection, then that transaction will be allowed. And then we have, all these rules are very, very similar. So we have another rule which is called edit changes. So remember, we have a change collection, and we want this rule to be triggered anytime anytime a transaction touches the change collection in any way. It applies to transactions and to queries. And the smart function that we want to run is just true. So just let this happen. So remember, by default, auth records don't have any sort of permissions. And this is a lot more secure. We want to think about what we're giving users permissions for. The next thing, and this is a very similar rule, is for purchase orders. So we want auth records with this role to be able to edit, transact, and query purchase orders. We want them to be able to view users. So for now, we're not giving our users permission to create new users. We could have an HR role if we want to build this out to do more. But we also have they have permission to view auth records. So again, no transact permission, just view permission. And then this is our very first, slightly more complicated smart function. We don't want users to be able to edit any user. We want users to be able to edit their own user. So remember, we created Edgar as a user. We want Edgar to be able to edit Edgar's own user. We don't want someone else to be able to edit his own user. So the smart function that we're going to run to check whether this is true is called edit own user. And here is the actual code. And this is a function that we provide for you, which is called relationship ? And relationship just checks whether there's a relationship between the two items that you describe. So we want to check whether there's a relationship between auth ID, which is the auth ID that's going to be issuing a transaction, and the subject that it's attempting to edit. In this case, the subject is going to be a user. And then we also have to specify a path. So the path goes from user auth to the ID. So basically, and like I mentioned, I'm not really going into this like line by line. So if you're curious about like the details of how this particular smart function runs, then we can talk about it later. But basically, just at a top level, understand that edit own user, this smart function, is just code that runs and checks, hey, is this auth record that's issuing this transaction connected to the user that we're attempting to edit? And so those are all of the permissions that we're going to create. And we're going to package them up into one big role, which we're going to call voter. And we're going to add that role, and this is really where we actually make the connection. We're going to add that role to every single auth record that we've created. So this is one way to reference the auth records. So remember the 5 auth records that we made. And we're going to attach the role of voter to that auth record. So you can see here that roles, first of all, is plural, but more importantly, the role voter is inside of square brackets. And that means that you can, if we had more roles, we could add them here. So an auth record can have multiple roles, but in this case, it'll just have one. So you can imagine, I'm issuing this transaction, you can imagine that the role governance can be quite complicated, but in here it's pretty simple, at least so far. Anyone's able to edit votes, changes, and edit votes and changes, but the only users, and purchase orders, I'm sorry, but the only users they can edit are their own users. It's pretty logical and straightforward permissions for now. And now One really cool thing about smart functions is that you can compose them. So if you create a smart function and you have it existing in your database, you can use that smart function to build up other smart functions. So we're going to create two smart functions in this transaction. One is called own-off, and this is just an equality check. So it checks whether the object that we're editing right now is equal to the auth record issuing that transaction. And we're going to be using this so that eventually down the line, so that people can only vote using their own auth record. So I can't, if I'm Edgar, I can't place a vote as Donna. But before we can get there, we need to make this smart function and put it in our database. And we're also going to be creating a vote where smart function. And this vote where smart function will just return a string. And so this code here is kind of long. And I should have mentioned, we use a subset of Clojure to write our smart function code. But there's really, I think, only maybe 15, 20 functions that we enable that are pretty big, like workhorse functions. So I don't think it's too complicated to learn all of those functions, but you can create kind of complex rules around those functions. So this vote where smart function will just return a string. And this string is going to be pulling information from the context that we're in. And so in particular, we're going to be building up this query, but rather than building up this query right away, we're going to have to use multiple smart functions to build up this query. And so remember I said that we want to have a requirement that in order for a person to change a purchase order's status to approved, there needs to be a vote in place with a certain threshold, right? So we're going to want to be able to issue a query checking any votes that are connected to a particular subject, predicate, and object. So again, let's say right now I want to issue a transaction. And I already have a purchase order in there. And my purchase order is with a subject ID 123. Oops. And I want to check the status of my purchase order, change the status of my purchase order to approved. So this is a transaction that I want to run. I want my smart functions to check for the subject ID 124. I want you to look up any changes that are referencing that subject. And then for the particular predicate, which is status, which is the one I'm editing right now. So this will be purchase order status. I want to see if there are any votes that reference approved. And I want you to spit that vote back out to me, right? So these like helper functions, SID, PID, and O, just return the subject ID in the transaction that I'm issuing, the predicate ID of the predicate I'm referencing, and the object that I'm changing. So the object in this case would be approved. So this is by far the most complicated smart function that we're going to see today. So if later on you want to go back to this is probably a good part to go back to. But I'm going to issue this transaction. And I'm going to do a little quick logic check here. So far, I've created, I believe, 3 functions. Okay. And I can actually select star from underscore function to see all the functions that I've created. So and here's the results of my query. So like I mentioned before, there's a built-in function called true, which just returns true, and a built-in function called false, which just returns false. But I also created a built-in function, or a function called edit own user, which we attached to a rule. And I've created 2 functions just now, which are not attached to anything. So vote where and own auth. And these are just functions that exist out in the ether, and for now, they don't do anything. But they have certain capabilities that we will be using very, very shortly. And now, oh, and I should mention too here, just quickly, this vote where function, I gave it a parameter, which is ref. So you can create any sort of parameters that you want. And we're going to be passing in a true or a false depending on whether the object I'm attempting to edit is a reference or not. And so the only thing that this is going to change is if it is not a reference, so it's a string, then when I create my query, it's going to put quotation marks, around the result of my object. But if it's a reference, then that's just going to be a long integer, and I don't need to put quotation marks around it. So that's what that parameter does. And now I'm going to create another function, which is called vote. And it's going to be using the vote where function that I just created, and it's going to be specifying a query. And it's actually going to be issuing that query. So you can see here that first, and in enclosure, kind of the functions are the operands, or the operators of the functions are the first item in a list, so query and then string. So first it's going to return this very long string, which is a query. And the string that I'm creating uses a previous string that I made, which was with vote where. So that's all the way over here. And so it's going to compose the result of my vote where function with some other string material, and it's going to return this query, which is actually, this query. But all of this material over here is already established using the vote where function. And then finally, it's going to issue this query. So I'm going to create this smart function. And again, if I select all of my functions, we can see it there, but it's not actually referenced anywhere, so it's not doing anything yet. You'll have to see in a second how we make it do something. So I issue this query. And now we can see that not only do I have my vote where smart function, I also have this vote function that I just created. And now my vote function, and I'm actually, so I think it might be helpful for me to issue this query for you so you can see. So I'm going to go to I'm going to go to a database that I already created. And I'm just going to issue this predicate. Okay. So we can see that here I just put in subject, predicate, and object as variables, but it pulls up, there's only one vote that I have in this example database here. So you can see that if I am, that this is a valid query that we can issue, and it's going to pull up any votes that fit the parameters that I've described. And now, we're also going to, so now this is the vote, here. This is the vote smart function. And now from the results of the vote smart function, I want to get yes votes and no votes. So I'm going to look at this one more time, and you can see that when I issue this query, it returns this array. So it's actually an array in an array, but the one that we wrote together is going to be an array. And they'll have reference to no votes, and it'll have reference to yes votes. And you can see there's one no vote and two yes votes. And so what I'm doing in these next smart functions that I'm creating is I'm getting all of the no votes. So first I issue that query, then I get nth 0, so the very first item in the array, and then I get this particular path, which is vote, no votes, and then ID. So this will just return a set of all the IDs that are no votes, and this will return a set of all of the IDs that are yes votes. So these are the exact same function, except instead of following the results to get the no votes, in the bottom one I'm following all the results to get the yes votes. And now I have an ability. So again, these smart functions for now, they just live in my database. I now have an ability to access for any given change that I want to make, all of the number of yes votes and the number of no votes that have been made. So I'm going to create a function that will tell me whether the number of no votes matches a minimum win percentage. So this function takes a percentage, and it also takes this other parameter, which we talked about before. But let's say this percentage is 50%. So it's going to count up the percentage of, the count of yes votes divided by the total sum of votes, and it's going to return true if that is greater than or equal to the minimum win percentage, or false if it's not. And then min votes is very similar to that. It's just going to take the count of all of my votes, so my yes votes and my no votes, and it's going to return true if it's greater than the minimum votes that we've established, or false if it's not. So I issue this transaction, and now I have a whole boatload of smart functions in my database, but I am not done. Now I'm going to create some sample vote thresholds. And these are pretty simple, but remember we can compose, or we've been composing all our smart functions, so I create one and then I can create a more complicated one on top of that and on top of that. So I'm going to create a function that is called toVotesMajority, which will return true if for a particular change that I want to make, there's at least 2 votes, and the vote threshold is at least 50%. I'm going to create a 5-vote consensus. So there needs to be at least 5 votes, and there needs to be full consensus for this to return true. 3-vote majority, and then the analog for all of those vote thresholds for objects that are references and objects that are not references. And I've issued this smart function. And here, finally, we're going to be able to use our 2-vote majority smart function that we've created, which will return true if for a given change, there's at least 2 votes and it's at least a majority. We're going to actually connect it to a particular predicate in our database. So we've done all this work to create the smart function, but it hasn't yet been, we haven't yet connected it to a particular feature in our transaction, so it's never going to be triggered. But here's actually where we trigger it. So I'm going to reference my predicate, which is purchase order status, and I'm going to attach to the spec, to the specification for that predicate, 2VotesMajority. So here's where the magic happens. In order to change my purchase order status, I need to have 2 votes and a majority to do so. And so these 2 lines are the most important, maybe in our entire demo so far. This is where we're connecting all of our smart functions and actually calling them. And just in addition, I'm going to also create a, I also want to make a requirement that in order to change the voting threshold, you need all 5 users to vote in order to change the voting threshold. So if we ever wanted to change this, you can't just have a single user change it, but all 5 will have to vote in order to make that change. And this is a little complicated. So what you might want to do right now is to add this specification to the predicate itself, that in order to change that spec, we need to have a 5-vote consensus reference. But if we were to add this in that very same transaction, then the smart function goes in place right away. So I can't actually add this specification until I actually have 5 votes to vote to make that happen. So that's a little confusing, and I can answer questions about that specific part later on if anyone has questions. But rather than requiring changes to voting thresholds to have a 5-vote consensus in this initial transaction, I'm going to create a vote first, and then I'm going to put it in place. So now here I am putting a voting threshold for changing purchase order status, and here I'm creating a change, and the change that I want to make is I want to change the predicate spec for predicate specs to be 5-vote consensus, and I'm creating a vote, and I'm specifying yes votes for every single auth record in my database. And later on this won't be possible because each user will have to vote for themselves, but for now I haven't put that in place. And I'm also going to create a vote. So later on, I'm going to create a spec that requires auth records to only be able to vote on behalf of themselves. So I'm going to attach that own auth record to the vote yes and vote no predicate specs, but I can't do that yet. I need to create a vote for that. And so here I'm just creating those votes and those changes as well. All right, and I issued the transaction, and now I can finally issue this transaction, which requires that any changes to voting thresholds have a full consensus and have at least 5 votes. So that happens here. And now for the very last bit, and we didn't add this before because it would have been wildly inconvenient, but I am going to require that any change to the yes vote predicate, the change that you have to put in there has to be your own auth record. So let's say, again, if I'm Edgar, then I can't put in Donna's auth record. I have to put in my own auth record. And so this is the smart function that actually ensures that voting is valid, that, this is the one that prevents voter fraud. And this is all of the smart functions that we've created so far. And I have a very simple React application that is already running that will allow you to see the results of what we've built. And this will all be packaged up together. So now we have 5 users in our database. And we can just click on a user, and it will pull up that user's information, and it will offer different actions that those users can do. And this is all packaged up in here. So it's just one probably not very efficient, but React component that has all of this logic in there that you all can look at later. But any sort of action that a user can take, we can select an action, and the transactions will be signed by that auth record. And this is all kind of stuff that I've hidden, but remember I'm essentially controlling all of the user's private keys. So let's say, the first thing I can do is I can propose a purchase order. And my purchase order form is very simple, but it's just going to be apples. So I want to buy apples as my purchase order, and I'm going to create my purchase order proposal. And now this has taken me to the action vote on purchase order approval. So here's my purchase order that I've just created, apples. I want to buy apples. And we can see that there's a yes vote and a 0 no votes. But my requirement to actually change that purchase order status to true is a 2-vote majority. So I'm going to go over here to my voting demo, and I'm going to see that I've created a purchase order. So here's my apples purchase order, and it has an ID, a name, and a description, but it does not have a status. And if I wanted to add a status to this purchase order, I would not be able to. Oops. So status approved. So you can see that this throws an error, and what I get in response is object approved does not conform to spec for predicate purchase order status. And why? Because you can't change that until you voted on it. That's one of the functions that we put in place. And so, I can go right here to submit purchase order and try to submit it, and it's going to throw an error. Again, very simple React application here. But if I select a different user and I go to vote on purchase order approval, and I have this purchase order here, and I click vote yes, you can see my vote number changes. So I voted yes, and I should have this 2-vote majority. So I have at least 2 votes, and it is greater than or equals 50%. So it's exactly 50%. And now any single user, it doesn't matter who, it could be Brad, can go to submit purchase order and click submit purchase order, and it's submitted. So basically what they've done is they changed the approval to the status to approved. So now we have purchase order status approved. And what we can, so we can just do this again, create another one. It doesn't have to be Edgar, it can be Candace. So oranges, I want to buy oranges, create this purchase order. And by default, when a user creates a purchase order, they vote for their own purchase order. And, Brad can vote no on it. Anna can vote yes on it. And now it has reached that voting threshold and we can submit it. All right, but I teased a little bit at the beginning that we can also change the threshold itself for voting, for purchase orders. And you can do this also in this little demo here. If you go to change PO approval requirements, it says the current requirement is a 2-vote majority. But I can't change the requirement itself unless I have a 5-vote consensus. So I'm going to first create a proposal to change this voting threshold. So I want it to be changed to 3-vote majority. And I'm going to press propose vote change. And now there's a voting process that goes in place for that 3-vote majority proposal itself. So I need a full consensus for this to go through. So I'm going to go in each user. I'm going to click on vote on PO approval requirements. I'm going to vote yes. So now we have 2 yes votes. Go to Candace. I'm going to have 3 yes votes. And just to show you, if I click submit PO approval requirement change, I don't have the 5 votes that I need. So if I try to submit this change right now, it won't let me. It'll throw an error and it'll say that this doesn't conform to the spec. So we need 5 votes for this to happen. So I click on Brad, I go and vote on PO approval requirements, I vote yes, and we're almost there. One last person, and Anna, she's gonna think about it. Do I wanna vote for this? Do I not? And she's gonna vote yes. And now we have the 5 votes that we need to change this requirement, and any given user, it doesn't matter who they are, can click on submit PO approval requirement, and they can change that approval requirement to actually enact it. So notice here, this says the current requirement is a 2 votes majority. I'm going to submit change, and now it has changed to a 3-vote majority. So very quickly, I'm going to create a new purchase order. Bananas. I want to buy bananas. I create this purchase order. And now, if I have 2 votes on this purchase order, that doesn't match my threshold. So if I've done everything correctly, if I press submit purchase order, this is going to fail. And it fails because we've just, remember, this just would have passed because we had a different voting threshold, and now it fails. So now we need at least 1 more vote for this to go through. So I'm going to vote yes for this. And now my purchase order can be submitted. All right, so thank you all so much for sticking through this webinar. This demo and all of this available material is going to be available for you to download once our next release is through. But I'm really excited you all were here with me today. So this is a little bit, maybe the most complicated example of smart function usage that we've shown to the public so far, because it's smart functions that actually govern the very way that smart functions themselves are used. So there's kind of like a meta level layer there. So I don't see any questions from folks, so I guess we can just log off now. And but thank you again very much for joining. If you do have questions in the future, we have a Slack channel, we have a support email address, anything that you're interested in. I see, oh, so if you want to, I see a hand. If you want to ask a question, you can just type it in, select the Q&A, and okay. Oh, sure, I can explain a flake again. So every single piece of information in FlurryDB is stored in the form of a flake. So you can see that when we issue a transaction, so I'm going to go here, I'm going to issue a block query. So this is just as of a certain point in time, these are the changes that I make. So you can see that every single point in time in our database is just made up of flakes. And those flakes are composed of 5 parts, but the first 3 are the most important. So the first thing is a subject. So that's the item ID that we're referencing. The next is the predicate, which is the feature of that item. And then the third is the object. So in this case, this item that we're referencing is a purchase order. That's just the ID for it. The predicate is the status. So the feature, think of it as like a table column or something like that. And then the actual value of that is approved. And so this is a standard standard data format. This is an RDF triple, but we extend it because we also have a concept of time and a true or false. So, you know, at a given point in time, a particular piece of information might be true or might be false. Cool. Oh, this is a great question. So I hope I've answered the flake question well. Dan, we can also talk later if you want some more information on that. But I got another question saying that a lot of the smart functions that we've built seem like validations that you would program into the API middle layer. And it's asking if you need a middle layer in Fluree. And so that's a really great question. So there is a lot of logic that you can put, a lot of rules and permissions that you can put directly into the database in FlurryDB. So if you're building a simple application, then you absolutely do not need to have that middle layer business logic. And what's really key is that this is way more secure than a middle layer business logic because it can't be counteracted, and you can you don't always know if you're looking at a database what sort of framework or infrastructure is built around it. In the case of Fluree, any sort of rules that you have built into your database, you'll always be able to reference. Even if they're not currently in place, you'll be able to see the history of your database, so you'll always be able to know what smart functions were, in fact, at play at a given point in time. And also, like, this is the way that we enable multiple parties to control the same database. Because we can't trust multiple parties to have the same middle layer business logic. That's not a very smart way to handle collaborative data. We need to have that we need to have all of that business logic in a place that's verified and that anyone can check, and it's reproducible. So that's what our smart functions allow you to do. Awesome. If there are no more questions, then we can call it a day. And it's been lovely talking with you all. And remember, we have our documentation, we have our Slack channel, we have our email addresses, and any sort of questions or anything that you built on top of this would be really, really awesome to see.